All right, this is going to be the second set of notes. What we're going to be going over in this lesson is going to be balancing equations, which is working off of what we went over yesterday or the last lesson. So in the last lesson, you should have gone over the law of conservation of mass, which basically just states that mass can either be created or destroyed. So for example, here we have this chemical equation that you should be able to interpret. We have the reactants on the left, we have the reactants on the left-hand side, products on the right-hand side, okay? So what's happening in the chemical reaction is we're not creating or destroying any type of matter. We're simply just rearranging it. So we're taking these atoms, we're rearranging them into a different form, but we're not destroying anything, okay? So this is pretty much what you guys did when you work with the stick and ball models. You guys were modeling the chemical reaction by moving things around. You weren't actually destroying anything, okay? For example, let's say we have someone that burns a log. If you burn a log, it's going to weigh less after, but mass isn't lost. What's happening is a lot of this trapped carbon in here and water vapor is going to leave, but it's just leaving, it's changing to a different form. It's not necessarily being destroyed, okay? So we're going to use that logic today to kind of figure out how to balance equations. So let's go into today's lesson. So I'm just going to work through a few examples, starting off simple and then getting a little bit more complicated. So this is the first example we're working through, which is, so we need to be able to balance this. Just wrapping this. Okay, so what I want to do is I want to balance this equation. I have AgN2, which is silver oxide, reacting to make silver and oxygen, okay? So I'm going to start off and kind of go through the steps real slow and detailed, and then we'll kind of speed it up. So I'm going to list the type of atoms I have. So I'll split this into to have the reactants on this side and the products on this side. So we know how to count atoms already, so we've done this before. Okay, so I have silver, I have 2 silvers. Okay, oxygen, there's nothing next to the oxygen, so it's invisible 1. I have 1 oxygen. Okay, cool. Now here, if this is blank, it just implies that it's a 1. Or so you could either leave it blank or you can put a 1. So for Ag on this side, I have 1. For oxygens, I have 2. Okay. According to the law of conservation of mass, if I have 2 silvers here, then I need to have 2 silvers here. Remember, this 2 represents the number of moles. If I have 2 moles of Ag here, then I should have 2 moles of Ag here, but I don't. Same thing with oxygen. I should have 2 oxygens on both sides because I have 2 here. That's not the case. So we have to balance this equation so both sides have the same amount of atoms. This side, so I can put numbers in front of this, and it's going to affect everything here. But I can't put numbers in between, okay? So let's go ahead and try to balance. Let's start by balancing the silver. I have 2 silvers on this side, and I have 1 silver on there. So the easiest thing to do is I'm just going to put a 2, and that gives me, now this changes. Now this is 2. The plus sign kind of divides these two. So if I put a 2 here, it only applies to the silver. It doesn't apply to the oxygen, okay? So that's good. This is balanced. This is balanced. I go on to my next one. So oxygen. I have 2 oxygens here. Sorry, I have 1 oxygen here, 2 oxygens here. So the simplest thing to do is put a 2. I put a 2. Now this changes this. Now I have 2 oxygens. Now I have, well, this is also balanced. This is balanced. However, because I put this 2 here, this is going to change. So that 2 applies to the silver. So now I actually have 4 silvers. Okay. All right. So now it's really a lot of just trial and error. Now I have 4 here, so I got to go back. I'm actually going to have to switch this. So rather than putting 2 there, I'm going to put another number. So it's trial and error. I'm going to erase this. So let's try a different number. Let's put, well, if I have 4 here, I can easily get 4 on this side by just putting a 4. I'm going to put 4. Well, 4 times 1 gives me 4. Now, this is 4, this is 4, this is 2, this is 2. Good, it's balanced, okay? And that's it. That's all you're doing today is you're balancing the equation. This would be your final equation. Here you can leave it blank, or you can put a 1. it's the same thing. Because a 1 times 2 still gives you 2. Okay. All right, let's work through another example. So that was a relatively easy example. We'll work through another one. This one, I'm not going to list all the atoms. I'm just kind of going to talk through it because you don't have to list all the atoms every single time. You can, but you don't have to. Okay. So let's just kind of work through it. Okay. So I have 8 sulfurs here. I have 1 sulfur here. Okay. And I have 3 oxygens and 2 oxygens. Okay. So you want to focus on one atom at a time. I can either focus on sulfur or I can focus on oxygen. I'm going to focus on sulfur because it just seems like the simpler one to focus on. It's just by itself here. So I have 8 sulfur here. So if I want to get 8 sulfur here, I would just put an 8 here, right? So now I have, actually, let me just list this out for you. So I have 8 of these here. We'll split this here. Now I have 8 sulfur here now, right? Because I just put that 8 there. Now oxygens I have, well, I have an 8 here, but I have a 3 here. So it's going to be 8 times 3. I have 24 oxygens on this side, right? How do I get 24 oxygens here? I have to put a number there. So what times 2 gives me 24? Well, it's going to be 12. 12 times 2 gives me 24. And that's it. That's the balanced equation. Okay, because if I did this here, well, I would also have 12 times 2 would give me 24. I would have the same amount of atoms on both sides. Okay. You don't have to do these steps right here. You don't have to list this out. The more you do it, it's going to become just trial and error. You can erase, try different numbers, and so forth. Okay, but I'm just kind of breaking it down for you guys so you can visualize it. Okay, let's work through a more complicated example. So I have this example. We haven't seen something like this because now we're dealing with an OH, which is a polyatomic ion. Okay, if you remember what a polyatomic ion is, it's just multiple atoms bonded together. Okay, if you remember that, those charts that we had where we had multiple things bonded together. Okay, so what I want you to do, there's one way to kind of work these problems. They look complicated, but they're not that complicated. What we're going to do is we're going to treat the polyatomic ions, and my polyatomic ion in this example is OH. We're going to treat them like they're one compound. So we're going to group them together. Okay, I'm not going to say O and then H. I'm going to say OH. It's like one compound together. I group them. Okay. All right. So using that logic, let's kind of work through this. So first, I'm going to balance the OHs. Okay. I have one OH here. Why? Because if you think about it, there's an invisible bracket and there's a 1 here. Okay. So I have one OH and I have 3 OHs on this side. So how do I balance that? Well, if I have 3 OHs here, then I need to put a 3 here. So I have 3 OHs here. Okay. Okay, that's fine. That's balanced. Now, that's changed my sodium though, because that 3 applies to this as well. So now I have 3 sodium on this side, so I need 3 sodium on this side. So I'm going to put a 3 there as well. 3. Okay, cool. All right, so this is balanced. These are balanced, right? This is balanced. I'm just going to put a check because I have 3 there, 3 there. I have 3 sodium. I have 3 OHs, 3 OHs, and then this is balanced. Okay. This 3 also applies to this chlorine. So I have 3 chlorine here, 3 chlorine here. So that's actually balanced itself too. Okay. Then I have 1 iron, because that 3 doesn't apply to the iron. There's an invisible 1 here. 1 iron. So everything's balanced. I can list it out like I did before, but it's all balanced already. Okay. And if you want to go ahead and put a 1 here, you can, or you can leave it empty. It's the same thing. Okay. Just gonna check on this recording. Just gonna work through the last example here. So this is gonna be our last example. So this one's a little bit more complicated just because if you notice, we have 1 atom here, but on this other example, oxygen is on both of these. So we have oxygen. So if I change if I change oxygen here, it changes this. If I change it here, it changes it. So this is a little bit more complicated because oxygen's on two separate atoms. It's not just on one. Okay. So what I'm going to do is I'm going to balance oxygen first. So I notice that I have two oxygens here. Let's start by balancing the oxygens. I have two oxygens here. Here I have, well, on one side I have 3, and then on this side I have 2. Okay, so you're going to notice on this side I have a total of 5 oxygen. This side I have 2. So I need to switch this and I need to make this into an even number. Why? Because whatever I put here, whatever I multiply, it's always going to be even. So if I go 2 times 2 gives me 4 even, 3 times 2, 6, and so forth. So I can't have this odd number because if I add them up, they're always going to be odd. They both have to be even, okay? Because this is always going to be even. So what I'm going to do is I'm gonna multiply this times 2 because there's an invisible 1, right? So I try the next number, which is 2. So I'm going to put 2. That changes this to, well, 2 times 3 gives me 6. Okay, so now we're fine. I have an even number of oxygens here. I have 6 plus 2. That gives me a total of 8. I'll write that down here. So I have a total of 8 oxygen in total on this whole side, right? Because I added this plus this. Okay, so now I need to get 8 oxygen here. So, well, 2 times something is going to give me 8. That's going to be easy. It's going to be 2 times 4 will give me 8. All right, so this is now 8. Now my oxygens are balanced. Now I can worry about the other atoms. So now I have 4 iron here because 2 times 2 gives me 4, so I got to put a 4 there. Okay. So now I have, in terms of iron, I have 4. In terms of sulfur, though, I also have 4. So here I have 4 iron because I went 2 times 2, right? And I have the only one we're missing is the sulfur. I haven't listed that here. I have 1 sulfur. Okay, so we notice everything kind of checks out. This is balanced. This is balanced. My oxygens are balanced, right? Because my oxygen is down here. I added these two to give me that number. Okay. However, there's one thing that it's not balanced, which is the sulfur. So when I put this 4 here, that actually changed this as well. It made this into a 4. So it's going to be kind of challenging because now I need 4 here. So I need to put a 4 there, but that's going to change my oxygens, right? Which is fine because it's a lot of trial and error. So what we're going to go ahead and do is we're going to put we need to get 4 of these, so I'm going to put a 4 here. Okay, so I'm going to put 4. Okay, so that gives me 4 sulfur now. So that's balanced. However, now my oxygen is not, this changes because I have 8 of these now, right? Because I went 4 times 2 gives me 8. All right, so now that means my total oxygens on this side are 8 plus 6, which is not 8. It's going to be 14. So this actually has to change. This can't be a 4. This is going to be, well, let's figure that out. 2 times what gives me 14? Well, 2 times 7. So this is actually 7. This is actually 14. Okay, and you don't have to do all this work. I just listed it so you see what I'm doing. So now it's balanced because I have 14 oxygens here, 14 oxygens, 4 sulfur, 4 irons. So this here, that would be my balanced equation. So that one's a little bit more complicated. That's why I left that one to last. Okay. If you have questions, just email me, and I'll also put another video below. For your assignment's going to be here. There's 2 parts to it. There's this part, and there's also the back part. You can do this on a separate paper and upload it onto Schoology. If you have a printer, you can also print this. So you just have to right click on it and then print this document, or you can open in Google Docs and then print it, and then just do it on. That will save you the time of writing the equations, or you can just do it all, write it on a piece of paper. Either way, it's fine. Make sure to submit that on time before the deadline.